Let's fiddle with Zeppelin, shall we? So Zeppelin comes pre-installed on Hortonworks, so all I've done is kick off my sandbox virtual box here, and that's all I need to do. So to connect to Zeppelin, all I do is open up a browser window and go to 127.0.0.1 colon. The magic port number is 9995 by default. So, and with that, we get our Zeppelin notebook interface. It's just been sitting there the whole time waiting for us. Amazing stuff. I love it when we just kind of like uncover hidden gems in our package here that's already sitting there waiting for us. So let's actually figure out what Zeppelin's all about. So like I said, it's a notebook interface to your cluster. What does that mean? Well, let's just make a notebook and figure it out. So click the Create New Note button here. And let's give this a name. Let's call it Playing with Movie Lens. Because what we're going to do is load up the Movie Lens dataset that we've come to know and love and analyze it through this notebook. So what we have here is basically a blank notebook that we can do stuff with. And there are many different things we can do. So first of all, what we're going to do primarily is run Spark code from within this notebook. So let's make sure that things are set up properly. Remember I said that Zeppelin has multiple backends, multiple interpreters that it can use. So you have to tell it how to prioritize those interpreters. So when it encounters code, it knows how to run it. To do that, just click on this little gear icon up here. And if Spark is not already on the top of that list, just drag it up there. You can just drag and drop things here. So put Spark on the top. MD should be second. And just hit save when you're done. And make sure that's all taken care of. So you can do more than write Spark code in here. Like I said, it's a notebook, so you can put your own little notations in here and make nice little documentation. So it's actually a very good tool for not only experimenting with code on your cluster, but also sharing that code with others and documenting what it's doing and what you were thinking when you wrote this stuff. So for example, I could write %MD. That indicates that this block is going to be in Markdown format. Markdown just being sort of a shorthand for HTML, if you will. And part of that markdown format is that if you want something in, emphasis, you can do 3 pound signs or hash signs, whatever you want to call them in this day and age, and say, let's make sure Spark is working first. And then we can just write some arbitrary text there and say, let's see what version we're working with. And so this is basically the code behind this paragraph in our notebook. And if we hit Shift-Enter, it will execute that code, and that's what it looks like. So if we wanted to hide the code there so you can just see the finished formatted results of that, we can click on this little Hide Editor button here, and you can see that we've written our first paragraph in our notebook. So it's just some pretty text that says, let's make sure Spark is working first. So now that we've said what we're going to do, let's actually do it. Now remember, we're using Spark by default as our primary back end, so we can just start writing Spark code and see what happens. Now in the notebook, in the Zeppelin notebook, Spark already is pre-initialized, so it has a Spark context object called SC and a Spark SQL object called SQL context. So we can just say sc.version, and that's all we need to do. So it's just like when you're in the Spark shell. You can just use SC right out of the box. So again, let's hit Shift-Enter and let that execute. And it's coming back with Spark 1.6. That's a little bit of a bummer because, the world's all about Spark 2 these days, so I imagine that will change in the not too distant future. So for now, we're going to stick with Spark 1.6 style code. And I'm going to actually use the Scala programming language for our interactions here. Scala is really the language of choice for Spark. If you're not familiar with Scala, don't worry, it makes sense. You'll pick it up as we go, but I'll give you some resources for learning Scala if you want to learn more about that later on. So another cool thing about these notebooks is that you can also execute shell commands from them. So if we want to actually import the Movie Lens dataset, we can do that as part of this notebook. So we don't have to assume that somebody's already loaded the data into HDFS for us. We can take care of that right within the notebook. So watch this. We can say %sh. That means we're going to be executing shell commands within this paragraph. And now we can do something like wget http:// media.sundog-soft.com/hadoop/ml-100k u.data, and we will output that -o to /temp/u.data. And we will also get the items data. So u.data, if you recall, is the ratings data from the Movie Lens dataset, all the individual movie ratings. And there's also a u.item file that we're going to get, which contains the mappings of movie IDs to movie titles. So let's get that as well. u.item, and we'll put that in /temp/u.item. Okay, and then when we're done, we can echo downloaded. So let's hit Shift-Enter to execute that. And sure enough, it went and got those two files and saved them into temp.u.data on our local file system. But we really want them in HDFS so that our Spark script can analyze them on a cluster, right? So let's do that next. Again, we'll just use shell commands to do that, and we'll use the Hadoop command, hadoopfs, to copy those up. But first, let's make sure there's no existing data there. If there is, we should remove it. So we can say -rm-r-f/temp/ml-100k. So the home in HDFS where I'm going to store this stuff for this notebook is going to be under the temp root directory and then ml100k. rm-rf means to recursively delete that directory if it exists and to force the command if necessary. And then, now that we know that it's not there, we can create it. So Hadoop fs-micdir, make directory, /temp/ml-100k. And finally, we can upload our data into Hadoop, into HDFS rather. Hadoop fs-put, and locally it will be on /temp/u.data, and we will store that into /temp/ml-100k. And we will also put up our item data, the movie titles. Put /temp/u.item, also into temp/ml-100k. Double check all that, make sure it looks okay. I think that's correct, and Shift-Enter, and we'll see that actually takes a little bit of time to run. Connecting to HDFS takes a little bit of time, but that should finish momentarily. And that's done too. Something else I want to point out too, in these little code blocks, you can also give them titles so you can kind of remind yourself what you're doing. So an example here, if I were to hit this gear icon, I can say show title. And from there I can edit the title of this paragraph and say copy data to HDFS or whatever you want to say. And that gives you a little mental reminder as to what this paragraph of code is all about, what it's trying to do. All right, moving on. So let's actually write some Scala code now to analyze our data. So let's load those ratings into a Spark data frame. So to do that, I'm just going to start writing Scala code. Remember, Scala is our primary interpreter, so we can just use it. So what we're going to do is first create what's called in Scala a case class, final case class rating. And that's going to consist of a movie ID that is an integer and a rating that is an integer. Okay, so this is just shorthand in Scala saying I'm creating a class object called rating that consists of two data members. One is an integer-based movie ID and one is an integer-based rating. And this allows us to very easily create a data frame in Spark from our raw data because it specifies both the format and the names of the columns in that data frame. Next, we can load up that data. So we can say val lines. So val is just Scala for, a immutable variable. Equals sc, again using the already initialized Spark context, text file, capital F, and we will give it the path on HDFS to our raw ratings data. 3// temp ml-100k /u.data. And now we're going to map that raw data, which is just tab delimited, like so. So we'll take each input line and map that to the following function. We will first extract every field that is tab delimited into a variable called fields using the split command. And then we will return a rating object that is constructed from the second and third fields. So we start counting from 0 in Scala, so we can say fields1.toInt, fields2.toInt, and the handy-dandy auto-completion already has the proper finish here of the various brackets and parentheses. So double check if you are following along here with all the proper syntax here. Make sure the capitalization is correct. Make sure you're not mixing up your curly brackets and your parentheses. And if it looks good, let's go ahead and hit Shift-Enter to kick that off. All right, so far so good. That warning's safe to ignore. Don't worry about it. Next, let's convert that to a data frame. So right now we have what's called an RDD in Spark called lines, but I want a data frame because I want to issue Spark SQL commands against it. So to do that, we say import SQL context.implicits _, and val ratings df for a ratings data frame equals lines, equals lines dot to df. So that converts our ratings to a data frame using that ratings case class to assign types and column names to that data as we go. And just to make sure that it imported properly, I can say ratings df.print schema to take a look at what we got, and shift enter. And you can see that worked, and we have a schema that consists of two columns. Movie ID is an integer and rating is an integer as well. So far so good. So now let's do something with that data frame. If we were just writing straight up Spark Scala code, we could do something like this to just figure out the top movie IDs, how many movies were rated the most. Val top movie IDs equals ratings df dot group by movie ID. So this is going to aggregate together all the ratings for a given movie ID and then count them up, dot count, and we will order them in descending order by that count and cache it in case we want to use that more than once. Why not? And then we'll show the results. Top movie IDs dot show should show us the top 20 results of that query. So let's hit shift enter here, see what we get. Now we're running an honest to God Spark job here in the background, and if I was on a real cluster and not just a single virtual machine, it might even be using the entire cluster for this. So it's pretty powerful stuff. That's kind of the whole point of Zeppelin. You know, it provides a very interactive and very quick and easy to use interface that makes it very easy to run code against your massive data sets using the power of your entire cluster potentially behind you. So kind of stop for a minute and appreciate what's going on here. It's a very powerful tool because of how easy it's making it to just mess around with Spark on massive data sets potentially. Anyway, here's our results here. So we've seen this before. Movie ID 50, of course, is Star Wars with 584 ratings, and I forget the rest, but well, let's fix that, shall we? So if we were to load in also the movie names information, the movie titles, we can merge that together with this data set and actually print out the human readable movie titles in this output. So that's going to be easier to do, I think, using SQL. So let's actually expose this information as SQL tables, and from there we can treat it just like a database within this notebook. So that's another cool feature of Zeppelin.